Hello everyone, welcome to Proof of Concept channel. Today we are going to see iris flower prediction using logistical regressions. So this proof of concept involves following 6 steps. Let me go one by one. First one is load the required libraries and then the import the datasets. We are going to use sklearn free dataset for this proof of concept, and then EDA explorative data analysis, model building, and then prediction on the test data, and then summary. So before that, for to execute all this proof of concept, you don't really require any software installation. This is just a colab.research.google.com. If you have a Google account, that should be enough. And you can just go to colab.research.google.com, and that will provide you the notebook. There you can execute all these commands. Similarly, we provided the website with all these commands, and then for your execution purpose, you can just use that and then copy paste into your Colab and execute all these steps. Okay, let's dive into the steps. The step one involve load the required libraries. So we need pandas and the numpy and the datasets that we are getting it from the load iris. So that's the sklearn free datasets, free to use. And the model, we are using logical regression here, and accuracy score, train test split. And we are doing some EDA analysis. For that we are using matplotlib and seaborn for the dashboard purpose. Let me explain what we are going to achieve as part of this proof of concept. So this is the iris flower predictions. So we have three types of iris flower: iris versicolor, setosa, virginica. So based on the sepal and the petal, sepal width and then sepal length, and petal width and then petal width, we are going to predict what type of iris flower it is. Let me quickly go to Google and show you guys. So if you go to Google and then just type iris flower prediction, you'll be getting a lot of images. So there if you see, so this is the petal length and petal width, and then the sepal length and the sepal width. So based on this, these are all the four features provided as part of this data sets. Based on these features, we are going to predict what type of iris flower it is. So we have three types of iris flower: versicolor, setosa, and virginica. So based on these four features, petal length, petal width, sepal length, and sepal width, we are going to predict, our model is going to predict whether it's a versicolor, setosa, or virginica. That is the objective of this proof of concept. Okay, let's go back to the step 2. So the step 2 involves import all the data sets. Before that, just execute all these load libraries. I'm just executing parallelly. Okay, so for the step 2, we are importing the data sets. We are using the load iris free data sets. Let me quickly execute and show how the data look like. So this is how the data look like. So if you see the sepal length, sepal width, petal length, and petal width. These are all the four features, and we have a target variable. So the target will type what type of iris flower it is. So that is the objective. And so these steps just explaining the features, the four features we have: petal length, petal width, sepal length, and sepal width. So that's the input to our model. Based on that input, our model can able to predict whether it's a versicolor, setosa, or virginica. So these are all our targets: setosa, versicolor, and virginica. So we are going to predict our the values based on the features we provided. And then let's quickly check how many records we have. So that will provide the data frame dot shape. So we have 150 records and 5 columns. So except four features, and one is for the target variable. So now we are in step 3. So that's EDA part, exploratory data analysis. As part of this step 3, we are going to see any null values or any missing value imputation required or not. Those are all the steps involved in this process. So let's see the DataFrame.info, and that will tell us how many number of records we have or any null value available, all those details. If you see, we have 150 records and all non-null, and the type also we can see as part of this from this. And quickly see any null values available. So the DataFrame dot is null dot sum, that will provide if you have any null values, that will provide you the number. Currently for this data set we don't have any null values, so we are getting the 0. And so these steps we are going to see, um, is any like the same step, the value count details for all attributes, so that will tell us like how many records we have. So if you see all four of the sepal length, sepal width, and petal length and petal width, all we have 150 records, and for the target also we have 150 records. There is no null based on this step. And you can use n unique to see how many unique number of records available, so that will provide you the unique number of records as part of our data sets. And so the data frame dot describe, that will provide you the count, mean, and the 25%, 50% details. So if you see here, no, like the sepal length we have 150 records, and the mean and median value is 5. So those kind of analysis you can do as part of this command. You can see what is the 25% of the value, 50% of the values, and 75% of the values, and then max values. All these things you can use using this data frame dot describe method. And so in this step we are going to plot our data. So we are using SNS dot pair plot, and see how the correlations for our data sets. So let me quickly run and see you guys. So here we can see our features. See, for example, we have a petal length, and we see some positive correlation, petal length and then petal width. If you see, this is the positive correlation. So whenever the length increase and the width also increase, so you can see the positive correlations between the petal length and the petal width. Similarly, petal length and petal width here, and the sepal width and then sepal length. So those kind of analysis you can do as part of this the plot. So that will provide you whether our features have the positive correlations or negative correlations. All those things you can validate as part of this. And this step, the same thing, but this will provide you the numbers. So if you see the petal length and then petal width, we are seeing 0.96. That is very good positive correlations. And if you have any negative correlations, you can see with the minus of the numbers, you can see the negative correlations also as part of this. And we are in step 4 right now. So we are going to build our model using the logical regression. So for this step 4, so we need to extract our the features as well as the target. So I'm going to take x equal to dropping the target from there, which means x contains all our features, which is sepal length, sepal width, petal length, and petal width. And the target, we are going to keep the y value. So now we extracted x and y with the features and the target values. And these steps will provide us to split the train and split test data. So because we are going to validate our model using the test data. So before training our model, we are extracting the 70-30 or 80-20 base train and test data split up. So this is the default the method given by sklearn, and we are just substituting x and y values here, and then doing the split over here. So this will give us the 70-30 split. You can perform 80-20 split also. So for this proof of concept, I'm using 70-20. So let me run that as well quickly. Now if you see our train and test shape, you can see that 105 and 4 and 45 and 4. So which means 4 columns and 105 records. So we have a test data ready, and we have a train data ready. So these steps, we are using our model, logical regression model, and we are giving the x train and y train to fit it. So now our model is ready. So our model is ready to use. For the next step, predicting the test data, so we are going to see predict the test data as well as we are going to see the accuracy of the model. Let me execute that as well parallelly. So if you see here, we got 0.97, which is 97% of accuracy for this model. So what it means is like our model can able to predict 97 values correctly out of 100 values. So 97% is correct. Whatever, if you provide the values in, if you feed the values into our model, that can able to predict 97% correctly. And so here we can see what are all the predictions we have. So the target variables, the predicted one, the below steps will show like what is our upside as well as the predicted values. Let me go there and to quickly show that as well. So these steps, like we took all values, so our observed flower name as well as the predicted flower name, and our test based on our test data. So what are all the input we provided to our model, and our model predicted that values, and what is the existing value and what is the predicted values. So let me show this step. Okay, so here if you see, we have observed flower name and a predicted flower name. So the predicted one is the output from our model. So our model predicted all these flowers. So for the first records, if you see, we provide the sepal length 6.2 and sepal width 3.4 and petal length 5.4 and petal width 2.3. So the observed flower name is Virginica, and even our model predicted correctly. Our model predicted it's a Virginica. Similar way, all these are the prediction based on our model predictions. And if you see um, the record, no, like there is the record 106. So our model predicted that's a versicolor. So when we substitute all these the features as a input, our model predicted this as a versicolor, but even the observed value also versicolor. So there is no wrong here. So most of them are correct. Our model predicted all those values correctly. So so we are coming to the summary of it. So far we learned how to load, how to import all the libraries that needs to build as part of this the model building, and we loaded the load iris datasets. That's sklearn providing the free datasets. So we used that load iris datasets, and we did some basic data analysis as well as part of that, and we extracted the 70/20 for the test and train, because we are going to use the test to validate our model. So that we completed already, and model prediction on the test data, and a comparison of the observed and the predicted flower details. So these are all the steps involved here. And all these steps we put it in our one of the web page. So if you go to localsfriends.com, so there we provided all these steps. It's free to use. You can just set up your Colab and copy paste all these commands and execute and get familiarized with the machine learning. So as part of this proof of concept, we building the logical regressions. Moving forward, we will include all our other models as well. So you can just use it and get familiarized with all these machine learning models. Thank you everyone. Thank you so much.